Hi everyone, I'm Amelie Chan, and today I'd like to share with you something that has both frustrated and inspired me for the past 10 years. From first stepping onto the ice to skating on Team USA last season, to now my first year doing my undergrad at MIT and joining the MIT Figure Skating Club, the sport of synchronized ice skating has taught me so many life lessons. But one of the lessons that I had to learn was that life isn't always fair. That this sport can sometimes get political, that human biases always exist, and as skaters, we put out the best skate that we can, and the rest is up to the panel. But you don't have to take my word for it. Figure skating at times is a world of drama. People still say that Yuna Kim was robbed of her gold medal in 2014, and they often speculate on whether certain teams get certain score bonuses. And statistical analyses have even shown that there's evidence of the compatriot judge effect, where judges will tend to score skaters from their own nation more favorably. And if it tells you anything, the top post of all time on r/figure skating is a very heated complaint against the judging system. To better understand how these controversies arise, let's take a look at the current scoring system. As the program is skated, the technical panel identifies the kinds of elements performed and calls a level of difficulty. Higher difficulty means a higher base value and more points. Meanwhile, the judging panel awards a grade of execution, which is essentially how well that element was skated. This acts as a either positive or negative multiplier on the base value. And when we tally up each of the elements, the base value and the multiplier, we get a total element score. Then at the end of the program, the judging panel is also responsible for rating the program's composition, the skater's performance and presentation, and their overall skating skills. And this constitutes the program component score. And of course, because ice tends to be a little slippery, there's always going to be the deductions, which are the falls or other kinds of downgrades. So, seems pretty straightforward, right? Well, even for just simply evaluating how well an element was executed, there's a whole laundry list of general and element-specific criteria that the judges need to be thinking about and considering for each and every element. But what's great is a number of these bullet points can actually be evaluated using artificial intelligence, which would share the task load with the human judges. And that sounds also especially helpful considering the complexity of observing 16 skaters on the ice at a time. Intentional biases or not, it's a tall task to accomplish in an entirely fair way. In the sport of synchronized ice skating, this particular discipline of figure skating, instead of jumps and spins, we have elements like circles, blocks, lines, and just shapes formed by the collective team, with an emphasis on synchronization. It's the name of the game. For a more concrete example, let's look at the moves element. From a technical standpoint, the tech is checking, for example, that the leg angle is above 135 degrees and held for a certain duration of time, and examining the pattern and formation that the skaters are skating in. Meanwhile, the judges are looking for flexibility, body control, and speed. In this case, with everyone kind of doing the same thing at the same time in the same area, looks pretty okay. But try it again with 3 different moves groups happening at the same time on a wider, more complex pattern, and it's impossible to keep track of everyone at all times. And that's where a Synchro bot can help. Just like any other team sport, we should consider both what the individual is contributing to the big picture and then consider the overall as a whole. And in the case of Synchro, unfortunately, there are no labeled datasets available, and as a lesser-known sport, there's a limited number of usable videos online. Essentially, we need to be doing more with less and be clever with our model's architecture and training. To accomplish this task, we'll use convolutional neural networks, a deep learning network architecture that is based on the way that human brains process images. To explain, CNNs work through layers, with each layer working to identify features and sliding filters across the image, detecting the presence of first low-level features like lines and edges, and then maintaining that information and serving it as an input for the next layer, which does it again until their number of layers is reached and you have the level of complexity that you're looking for, which in our case is looking for the overall shape formed by the skaters' bodies. By repeating this for the features until this point, we now have a hierarchical representation of the image. During the training process, it learns on its own what filters are most effective for detecting these features without being explicitly told what to look for. Keeping our limitations in mind, our training data is going to need labeling. What we can do is hand label clips of videos with different elements with the element type, and then also extract video commentary, scorebox information, and competition data to automate this process. Then we can split each labeled clip into frames with the same label that will serve as our training data. And to further allow for generalizability of our model and to avoid overfitting the data, we can perform alterations to the image that would further augment our data set. To then observe the individual contributions of a skater, we can use a CNN to detect skaters in the frame and create bounding boxes. Then, with use of pose estimation and calculations, we can help view the technical criteria, for example, measuring the vectors and calculating the angle between the skater's legs, or detecting whether the skater's foot is higher than their head. This can also be used to point out unison. It can suggest moments of unison to the judges, and if the skater's limbs' angles are all parallel vectors, then they must be matching. However, when skaters are in uncommon positions, a CNN that is trained on normal pose estimation datasets will ultimately fail, which is why we can resolve this by pre-training our CNN using the shuffle and learn method developed by researchers at CMU and Facebook AI. It is a sequence verification task that makes it possible to train a model to learn unsupervised with meaningful results. So to train, it'll extract 3 frames from a video, either shuffling it or not, and guess whether or not that sequence is temporally correct. And yes, that is me falling. But what this allows us to do is utilize the extensive data set that single skating, pair skating, and ice dance has as alongside these simple rink videos that are available across the country. Through this process of sequence verification, the model can gain a sensitivity and an intuition specifically for pose estimation for figure skating. In using deep learning to observe both the individual and the team, we can take steps forward on this path towards automating scoring aspects in synchronized skating, mitigating human biases, and contributing to a fairer world of figure skating. But it's clear that the possibilities are endless. If fairness to us means to use accessible resources, this could easily be tweaked for coaching and self-feedback. We can see applications in similar sports like synchro swimming and team dance, but there's obvious potential also in applying creative training and pose estimation to other sports. With a world like today and the latest technology at our fingertips, it's up to us to question what we personally want to do with it and what changes we personally want to see with the world. This is my SynchroBot. What will yours be? Thank you so much.